Yeah. That's the way every day goes.
Good morning, everyone. Today, our group will present our project about database design for Mixue, and I will explain about background for Mixue. Mixue Beijing was founded in 1997 in Sichuan, China by Zheng Hongchua. It started as a small, safe, high store with very limited equipment and a small budget. Even though the business faced many challenges, Zheng Hongchua never gave up. He continued to improve his recipe and products. After several years of hard work, Mixue expanded from selling safe ice to offering soft serve ice cream and bubble tea. One of the reasons for its success was its affordable price, which attracted many customers. Because of this strategy, Mixue quickly became popular across China and later expanded to Asia. Today, Mixue has over 19,000 branches, making it one of the largest food and beverage franchise brands in Asia. In Malaysia, one of its branches was opened in Aeropolis on 12 July 2024. This location was chosen because it is close to UiTM Technology Mara, UiTM, and College Metropolitan Police, where many students live and study. The area also has high customer traffic, which helped the business attract many customers. Since opening, the brand has continued to receive strong customer support. Now, I will explain the organization chart for Mixue. At the top of the organization is the area coach. The area coach is responsible for monitoring several branches, ensuring each store follows company standards and helping improve overall performance. Next is the store general manager, who manages the daily operation of the store. They are responsible for sales performance, staff management, customer satisfaction, and achieving business goals. Below the store general manager is the assistant store manager. The assistant store manager supports the manager by supervising employees, handling schedules, solving daily operational issues, and ensuring everything runs smoothly. The next position is shift leader. The shift leader is responsible for leading the team during their shift, assigning tasks to employees, maintaining service quality, and making sure customers receive excellent service. Below the shift leader is the supervisor. The supervisor monitors the work of the staff, ensure company producer and help solve operational problems and reports the management teams. And finally, we have the tea barista and cashier. They prepare drink and ice cream, serve customer, operate the cashier, maintain cleanliness, and provide friendly customer service. They play an important role because they interact directly with customer every day.
So for daily operations and data needs, the company has to manage walk-ins using an Excel system to record purchase data with accordance to customer chosen product. The data recorded in the system are only the product chosen by the customer, type of payment, and they also have to print out the customer's receipt and manually process customer pre-order in physical ledger. For the physical ledger, the ledger is left in the store to ensure it doesn't go missing every night. And the data recorded inside the physical ledger for pre-order customers are the customer's name, phone number, type of payment, and product chosen by the customer. There's another physical ledger left in the store for inventory count to ensure inventory there isn't a short of product inside for inventory, and there is to ensure the ledger doesn't go missing. It's left in the store also with the pre-recorded customer ledger. And then currently, the company manages fragmented data, including walk-in, sales, purchase data, customer chosen product, type of payment, pre-order customer profile, and inventory data.
Moving on to our problem management analysis, we have identified 4 key operational challenges. 1. Difficult in monitoring inventory. Due to the lack of a centralized database system, there is a significant risk of overstocking or inventory shortage, which can lead to unnecessary waste. Second, difficult in monitoring pre-order customer. Relying on a physical ledger to record pre-order data increase the likelihood of human error, which can result in an unhappy customer and negative impact of company's reputation. Third, Difficult in data retrieval. Because records are stored separately, searching for information become difficult. This leads to communicate gaps, overlapping information, and ultimately delay in daily operation. Lastly, human error. The continued use of physical ledgers of data enter significantly increase the potential of error. This create issue with overlapping, timeless, and miscommunication, which disrupt daily workflow. To address the problem we just discussed, we are proposing the Mixue sale and inventory management system. The core goal of this system is improve business operation by transition of manual recording to a computerized database system. Our proposed system is designed to handle several critical areas. One, it manage customer order and settled transaction. Second, it track product inventory and supply record. Third, it also oversee payment and automate report generation. By storing data in a centralized database, information become much easier to access, update, and monitor. Ultimately, this system will help reduce human error, avoid data duplication, improve inventory tracking, and generate automated reports to support better business discussion and overall operation efficiency at Mixue.
Okay, this is our objective of the database. First, to identify the requirement for Mixue sale and inventory management. Second, to design a database that can manage sale transaction, employee record, inventory, and customer information efficiently. And lastly, to develop a database system that improve data management, reduce human error, and support daily business operation at Mixue.
Moving on to the technical foundation of our proposed system. This slide illustrates our ERD design or entity relationship diagram. This diagram serves as a blueprint for our database, such as mapping out the relationship between the different entities within the major system, such as our order, product, customer, employees, and inventory record. By clearly defining this relationship, we ensure that our centralized database is organized logically, which will ultimately allow of efficient data retrieval, accurate reporting, and seamless system operation.
Now, continuing on with implementing the database project, essentially we are implementing our project into SQL. As there is a total of 10 questions, and I will be only answering 4 of those. So for A, B, C, and D. First, A, two SQL statements to create and eliminate database. So essentially, it's telling us to create a database and then eliminate it. So to create a database is as simple as typing create database and then the name you want to call your database. And it will show you if it's created or not. And on your left hand side, it will also show the database created, and you can select it and you can start entering data if you want. And then to drop the database, simply type drop instead of create database. And then the database you want to eliminate. So for our case, it's the same. It should be, and it will eliminate it. And from your left hand side also, from the left of your screen, it will not show the database anymore, and it will any data inside it will completely be erased. Continuing on to question D, a pair of SQL statement to create the table. To create a table that has relation to each other in the database. So it's telling us to create a table that has a relation to one another. So for our case, employee has a relation in cells, where an employee primary key is the cells foreign key, meaning it's connected to one another. Where yeah. So first we have to create the employee table before we create the sales table that has the foreign key from employee. So create table and the name of the table, which is for our case employee, and then primary key. Always start with primary first. And for our case, it's employee ID, INT primary key. You have to highlight it as primary key and then continue and fill in the rest of your information that is inside employee, and then close it off. And then after that, you have to create another table that has relation with the first table. So for our case, it's cells. So if the cells has a primary key, I will start with primary key and then fill in the information that is inside the cells. And then last, put foreign key last, just to, and then the foreign key, so typing foreign key, employee ID, the primary key you want to place, and then reference, where is this employee ID you're getting from? So for our case, it's employee, table employee, and then employee ID. Now continue on to question C. Two SQL statement that list significant information from a single table. So he is telling us to list a significant informations like data we place, like names of the product, or maybe you want to find if things are out of stock or on stock, the name of a customer, the number of the customer, or data in a single table also. So we've created two, since you want us to create two SQL, we did create two SQL statements. So first, we are trying to find product that are out of stock. So select, we've already created the table before this, so everything's in Java. So first select product name, category, and unit price. So we have to this product name category. So this is the things that we want the SQL to list out. We do not want any, every information from product where we are getting the information from. We do not want to list every single time, every single thing. So that's why we select only these three things, because we only want to know these three items. And then where do we want, where other information we want to know is product status. So, and we are trying to find out of stocks, and then you close it off with a comma, whatever that is. And then it will, and then press go, and it'll usually list out the information. It will list out the information that, for our case, things that are out of stock, which is these two things. And then continuing on, the second statement, SQL statement, is our employee. We want to find our employees' last name, first name, and their roles. And then so select first name, last name, role, and from where. So from employee. This is a simplified version of the one above, because we are trying to find we are not trying to find things that are out of stock, or things that are available. So it's a simplified version. We do not need to write where. And then continuing on to question D. One SQL statement to list significant information from tables that has relation without using join. So it's telling us to create one SQL statement that does not use join, and that has a relation with, and and you have to list down information from tables that has a relation with one another. So in our case, a customer order from, as you can see, from customer order, and then select, we want to list out their first name, their last name, and then their order ID and order date. So we want to know customer's first name and their last name, their order ID, and when they ordered. So, and then from customer and orders, and where do we want, where are we going to list it up? Where are we going to find the information that we need? So type where customer, customer ID, and equals to order ID. So equals to is technically join. So
On this slide, we show two SQL statements that retrieve meaningful information by joining related tables. The first query uses an inner join to connect the employee and orders table using the employee ID. It displays the employee's first name, role, order ID, and total amount. Then sort the result by the order date in ascending order. The second query uses a left join to combine the product and order item tables using the product ID. It displays the product name, unit price, and the quantity ordered. The results are sorted alphabetically by the product name. This slide shows three SQL statements using different conditions to filter data from the database. The first query uses a comparison operator to display orders with a total amount greater than or equal to RM15. The second query uses the in clause to retrieve products that belong to either the ice cream or milk tea categories. The results are sorted by unit price in descending order. The third query uses the like clause to find customers whose phone numbers start with 01. The results are then sorted by loyalty points from highest to lowest.
Okay, let's go to the SQL column function. For our first query, this query join the employee and order table. We use the count function to count how many order each employee has handled. And then we'll be using group by to group the result by employer that has handled the order. From the output, we can see that Chong handled the most order out of other people. To the next SQL, this query join the customer and order table, different from before. Then we use the sum function to calculate the total amount spent by each customer. From this, we can see who spent the most in the shop, and we can see who's more loyal, and will maybe can know who will come here again. This is an example of using the having clause. After grouping the employer, we use the having clause to filter the group. Unlike where we filter individual row before grouping. Having filter, the group result after the count function has been calculated. From this, we can see the only employer who handle more than one order are the only one that has been displayed. In this case, we can see that Chong, No, Suresh, the three meet the condition to be displayed. Next, we will go to a customer who spent more than 20 ringgit. This query calculate the total spending for each customer first. Then, after that, we'll be using the heavy clause to display only customer whose total spending exceed 20 ringgit. We can see for the result that David, Muhammad, Durul, and Siti, because all of them, 4 of them, spend more than 20 ringgit. Okay, let's talk about sub-query. This is an example of a sub-query, which means one query is placed inside another query again. The inner query that we see calculate the average unit price of all products using the average function. The outer query then display only the product whose price is higher than the average. So for this result, we can see that the product like strawberry milkshake, mango pomelo sago, brown sugar pale milk tea, and supreme mixed milk tea have price above average. So they are displayed in the table.